Hello, in this video I will talk about the most fundamental structure of matter. An atom is the basic building block of chemistry. It is the smallest unit into which matter can be divided without the release of electrically charged particles. It is also the smallest unit of matter that has the characteristic properties of a chemical element. The atom is the most basic structure of matter, and the components of the atom are particles of matter. There are different types of atoms called chemical elements. The first chemical element is hydrogen, which consists of a proton found in the nucleus and an electron that rotates around the nucleus. Then we have the helium atom, which consists of 2 protons and 2 neutrons in the nucleus of the atom and 2 electrons orbiting the nucleus. The carbon atom contains 6 protons and 6 neutrons in the nucleus and 6 electrons, 2 of which orbit close to the nucleus and the other 4 electrons orbit farther away from the nucleus. What is a molecule? A group of atoms connected by a chemical bond is called a molecule. For example, the water molecule is H2O, consists of 2 hydrogen atoms and 1 oxygen atom. The chemical formula of water is H2O. Another example of molecule is carbon dioxide. In chemical spelling is CO2, and it is a gas at room temperature. Each molecule of CO2 consists of 1 carbon atom and 2 oxygen atoms. 2 oxygen atoms linked to it by a double covalent bond. Pure carbon occurs in 2 common forms in nature, diamond and graphite. Okay, what is an elementary particle? An elementary particle is a particle that is not composed of other particles. Particle physics describes how the other particles are composed of elementary particles. For example, the atom is made up of smaller particles that are electrons and protons and neutrons. The protons and neutrons in turn are made up of more elementary particles known as quarks. The study of elementary particles is another step in man's efforts to understand the structure of matter. It is estimated that there are fewer than 10 to the power of 87 individual elementary particles in the visible universe. Today, 17 elementary particles are known. Those are the 17 elementary particles. And another corresponding antiparticle for each of them. So we have 17 elementary particles and 17 elementary antiparticles. Of these two quarks and the electron make up the matter surrounds us every day, and four others made the fundamental forces in nature. So the four others that mediate the fundamental four fundamental forces are the four that are in a red color, the four particles. On March 14th, 2013, the physicists at the particle accelerator in Switzerland announced that they are largely convinced that the particle they discovered is indeed the Higgs boson. Okay, that is the Higgs boson. Experiments in particle accelerators are focused on finding an answer to the question which still remains open. Do more elementary particles exist, or does the standard model provide the final answer to the most basic structure of matter? Okay, so as I have already said, there are a total of 17 elementary particles, which include 6 quarks. The particles in the purple color are the quarks, the 6 quarks, and 6 leptons. In the green color, there are 6 leptons, and 5 bosons. That in the red color, we have 4 bosons, and the 5th boson is boson Higgs in the yellow color. Okay, what is quark? Quark is one of the elementary particles, the most basic building blocks of matter known today in physics. Okay? And we have, as I already said, 6 quarks. A lepton, what is lepton? Lepton or leptons are a group of elementary particles with half integer spin. So the particles in the green color, we have 6 leptons, that is to say fermions, which don't react to the strong force. So the leptons don't react to the strong force, that is the force that binds the protons together in the nucleus of the atom. In the sorting of particles, leptons form a group of corresponding group to the group of quarks. So, because we have the group of 6 leptons and 6 quarks. Okay, and what is the boson? Boson or bosons are force-carrying particles whose spin is an integer, unlike fermions. So we have here 4 bosons that are actually force-carrying particles. They carry the 4 fundamental forces in nature. Okay, as I already said, it is the strong force, the weak force, the electromagnetic force, and the gravitational force. And those four forces are carried by those four particles, except for the gravitational force that is carried by graviton, that is not in this picture, because it is not in the standard model. We don't have the graviton, because we doesn't find yet the graviton, but the scientists assume that the graviton does exist. Okay, so the bosons, the four bosons, and also the fifth boson has an integer spin, unlike the fermions that have half spin. Okay, and these particles, the boson, may be elementary particles like these particles, or composed of other sub-particles. These particles often allow the transfer of force between fermions, which are particles of matter. As I already said, the four boson particles allow to transfer the four fundamental forces between the fermions, that are quarks, and leptons, that are considered as particles of matters, the quarks and the leptons, and the bosons are particles of force. According to quantum field theory and the standard model, the four fundamental forces in nature are the strong nuclear force that binds the protons together in the nucleus of the atom, the weak nuclear force that is responsible for the radioactive decay of atoms, the electromagnetic force that explains how charged particles interact with each other, and the gravitational force that explains why metals or two objects with mass are attracted to each other. Okay, so those four fundamental forces are carried by four families of gauge bosons, which are 13 elementary subatomic particles. We have gluon. We have actually 8 types of gluon, 1 type of photon, 1 type of boson Z, and 2 types of boson W. So in total we have here 12 subatomic particles, and the 13th subatomic particle is the graviton. It is not here, and the scientists assume that this particle does exist, although we doesn't find that particle. Okay, so photons that carry the electromagnetic force have spin 1, they carry the electromagnetic force, okay? The force that explains why electrically charged particles, how they interact with each other. Then we have the gluon that carries the strong force, the force that binds the protons together in the nucleus of the atom. And we have 8 types of gluon, and the W and Z bosons that have spin 1 and carry the weak force, the force that actually explains the radioactive decay of atoms. The force that is responsible for the radioactive decay of atoms. That are the boson Z and boson W particles. Okay, and the 13th particle that doesn't exist in this table is the hypothesized graviton that has spin 2 and carries the force of gravity. Okay? According to the Standard Model, there is also a Higgs boson, that is the Higgs boson, which has spin 0 and determines the valence of the other particles, and the field and the particle provide a confirmable hypothesis for the origin of the mass in the elementary particles. So, as I have already said, the boson Higgs actually provide mass to the elementary particles in this table. As you can see from this table, only the photon and the gluon doesn't have mass, but all the other subatomic elementary particles have mass, and that mass is provided by the boson Higgs, and we can say generally that boson Higgs is responsible for the mass that we have in matter. Okay? The existence of the Higgs boson stood as a hypothesis for several years, but in July 2012 it was announced as part of an experiment conducted in Switzerland that there was 99.9995% certainty of its existence. Okay, thank you very much.